Start section 4.4 with the remainder theorem, which states that if I evaluate a polynomial at any point A, then I get the same value as I do when I divide x minus a and get the remainder. So let's see how that works in action. So this works with your the homework problems from 1 through 6. So we're going to find the following value of using synthetic division, and then we'll check it by substituting into the function. So if I use synthetic division to divide by x minus a, I should be able to get the remainder should be equal to p over 3. So here a equals 3. So we're going to divide that polynomial by x minus a. And we're going to start with using synthetic division. So that is, so remember we put the corresponding 0 over here on the left, so that's going to be the 3. And then I leave space for 2 lines of numbers and draw a long division bar. And we're going to be multiplying and adding instead of dividing and subtracting like we do in long division. So I need to rewrite my polynomial so every power is represented. So since this is a 5th degree polynomial, that means I need a 5th, 4th, 3rd, 2nd, 1st, and the constant. So I'm going to have 6 terms. So I should have negative x to the 5th. There is no 4th term listed, which means I need to use a placeholder. And then we have x cubed. There is no x squared, so I need a placeholder. And there's my x to the 1st and my constant. Okay, so now my coefficients come down into my synthetic division table here. So here I have a -1, then a 0, and a -3, 0, 2, and -1. So now to divide, I start by bringing down my 1. Actually, I'm going to use a different color. So I bring down the 1. Oh, sorry, -1. And then I multiply this number times this number and put it here, and then I add these two. And then I multiply these, and then I add. I multiply, add, multiply, add. Okay. So 3 times -1 gives me -3. And when I add 0 and -3, I get -3. 3 times -3 gives me -9. And when I add -3 and -9, I get -12. 3 times -12 gives me -36. And when I add 0 and -36, I get -36. 3 times -36 is, let's see, 90, 108, -108. And then when I add 2 plus -108, I get -106. And when I take 3 times -106, I get -318. And then adding -1 and -318, I get -319. So according to my synthetic division, my remainder equals -313. All right, let's keep that in our hat for a minute while we test that remainder theorem out. So now we're going to check that value by substituting the value into the function. According to the remainder theorem, I did the polynomial divided by x minus a. I should get the same result. My remainder should be the same as if I had evaluated that polynomial at a. So let's try that. Okay, so I should get the same result if I take p of 3. And p is negative x to the fifth minus 3x cubed plus 2x minus 1. Now if I plug in a 3 for all those x's, I get negative 3 to the fifth minus 3 times 3 cubed plus 2 times 3 minus 1, which gives me a negative 243 minus 3 times 3 cubed is 3 to the fourth, which is 81, plus 2 times 3 is 6, and minus 1. And that gives me negative 243 minus 81 gives me a negative 324 plus 6 minus 1 gives me negative 318, adding these two, and then subtracting 1, I get negative 319, which indeed is the same.